Hello everyone. In this video, we will be discussing the topic of hydrology. So let us start with the introduction to hydrology. Introduction to hydrology. So on the first concept, let us discuss about the basic concept of the hydrology. The first is the water is vital for all living organisms on earth. As you know that water is the life giver element on our planet. Each and every life form which is existing on this planet has started its journey from water itself. So, for life to continue on this planet, the water is very important. So, you can see here that water is a vital for all organisms on this earth. So, for centuries, people have been investigating where water comes from and where it goes, because water is like a resource to us. So, the resource we have to manage. So, we need the information, the amount of water, where it is coming from, and where it is going. So, where the water comes from and where it goes. Why some of it is salty and some of it is fresh. Salty water we can find in the oceans, and fresh water we can find in the rivers, streams, and lakes. Why sometimes there is not enough and sometimes too much water? Not enough water in the cases of droughts where the rainfall is less or the rivers have dried up or the groundwater level is low, there we can say that water is not enough, and sometimes too much in the cases of rainfall, too much excessive rainfall or monsoon period that is also under study. So all the questions and answers related to water have been grouped together into a discipline. That discipline is now we studied as the hydrology, the study of water. So the name of the discipline is hydrology, and it is formed by two Greek words, hydro and logos, meaning water and science, which means the science of water is known as the hydrology. So what is hydrology? Then we can say, if somebody asks that what is hydrology, it is the science of water. Simply the science of water. It is the science that deals with the occurrence, circulation, and distribution of water of the earth and earth's atmosphere. Okay. The water in any state which is present in our earth in liquid, gas, or solid form, the study of in all these forms comes under the hydrology, where it is starting to the starting of the rainfall, and then where the water is flowing, then where the evaporation is taking place, and where the clouds are forming. All this is comes under the study of the hydrology. So that is what is saying the occurrence, circulation, and distribution of water. Okay, where the water is being distributed throughout the earth. So a good understanding of hydrological process is important for the assessment of water resources, their management and conservation on global and regional scales. So when we talk about water as a resource, so we have to manage that, how much quantity of water is available with us and how much of it we can use, and what are what type of wastages. When we talk about don't waste water, save water, so that concept comes from this idea that water is a resource which we cannot waste, we have to manage it, we have to utilize it. So that conversation can go on a global scale, where the countries together come together and make a plan to how to conserve or effectively use the water, and or regional scales. These are like local scales where each individual unit, like one house or a single person, can also treat water as a resource, and they can also start their individual ways of saving and managing the water. So that is why we are talking about that the assessment of the water resource. This assessment is very important, that how much water is available with us, what type of water is available with us, and what is the quality of water. Okay, so that is also very important when it comes to the hydrological process. Next, Now we talk about the engineering hydrology, how we study the engineering part of the hydrology. Okay, so in general sense, engineering hydrology deals with number one, the estimation of water resources. In when we talk about the engineering sense, we will put water on a resource scale. So in order to utilize the resource, the first things comes the estimation of water resource, that how much water is available, how much water will be available in the coming years, if there is a shortfall of water or there is an excess of water. So estimation of the water as a resource, whenever we are planning any water system where we will be putting water or supplying water to the community or to factories there for irrigation purposes also, then we will first estimate the amount of water, that how much water we can totally use and how much we can distribute. Okay, so the next point is the study of processes such as precipitation, uh, trans evapotranspiration, runoff, and their interaction. These are very important because precipitation is a sort of water adding resource, which where we are getting the water as a resource. The water is being available to us, the quantity of water is increasing. Then there is evapotranspiration, which is known as which is a type of loss of water. The water which is available with us through transpiration and evaporation, that water is getting lost, which becomes the water becomes as a water vapor, and it is no more a resource for us. Runoff is kind of the water which runs on the surface after precipitation. If we do not tap that water or we cannot collect the runoff, that also goes into the drains, and it becomes less usable. And interaction is how these processes seamlessly go about in the ecosystem, and how we can use each and every resource at their correct point. Next is the study of problems such as floods and droughts, strategies to combat them. Okay, strategies to combat them. Here there are two important words. The problems which are discussing, that how we will get the people out of the problem. The problems are, one is the flood which is occurring, and other is the drought. Okay, and we have to come up with strategies to combat them. So we are not combating the flood, we are not combating the drought. Flood is a natural process which we cannot stop, or drought is a natural process which we cannot stop. But flood means there is an increase in the water which is available in that area. Drought means there is a decrease in the available water over area. So the excess water which is over there, if it is managed, it can be stored in certain areas. You can store that water, and that stored water can then be again used in cases of drought. Okay, so when we are talking about the engineering point of view, we will study flood as an excess of resource, and we will study drought as a where there is less resource, or the resource level has depleted. So how we can manage both the excess, and we can use it in the areas where there is very less resource. Okay, so for that, we need to first understand the hydrologic cycle. Hydrologic cycle is very important to study because the water exists on the planet as in three stages, liquid, solid, and gaseous. Okay, liquid like these, it is shown like streams, rivers, oceans, and lakes. Frozen is like solid is the frozen ice. When the snowfall is there, glaciers are there, and the snow-capped mountains are there. That is the solid form. And then the gases is the moisture or the clouds which are forming, and the evaporation, the normal humidity levels, that are also the gaseous form of water which is there. So the three of them are same. They are water, but in different states. So we can have to see that how can we utilize water when it is in its liquid stage, how we can utilize when it is in solid stage, and how we can use it as when it is in its gaseous stage. Okay, so let's talk about the hydrologic cycle. This is very important, hydrologic cycle. So water, irrespective of its different stages, involves dynamic aspect in nature. What is the dynamic aspect? That in even if it is present in liquid, solid or gas stage, it has its own characteristics. Water is, when it is flowing in regular quantities, it is okay. Excess quantities, we have discussed that it will become flood, or there will be drought if the water is less. And when it comes to the solid stage, when the snowfall is there in higher regions or on mountain tops, or in the North Pole and South Pole, where there is glaciers and there is excessive snow cover, then it is in the solid state. It can cause damage, like when in North Pole the ships which are traveling in that area, those ships can get stuck over there. The most famous example is the Titanic ship, Titanic, which was drowned in the ocean through a iceberg. Iceberg is the solid form of water which damaged the ship, and it caused the ship to go down and sink inside the ocean. So, like similarly, the gaseous state where the clouds are present, in hot regions, less clouds are present, there is less moisture. And in regions which are tropical regions nearer to the ocean, there is high moisture and high humidity levels. So those lack of humidity in the air also changes the ecosystem of that area. High dry areas which are very arid, where there is no moisture, plants do not grow there. Very less plants like cactus and other things can grow. And in high humidity areas, there will be abundance of greenery. There will be plants which can easily survive in that environment. Then they can flourish in the exchange of moisture also. So that is the dynamic aspect. So the state of water which is present in that area will govern the ecosystem of that area. Okay. So next, the dynamic nature of water. The existence of water in, say, various states with different hydrological process result in a very important natural phenomenon, which is known as hydrologic cycle. So hydrologic cycle, how it will interact with the environment that we need to study. Each and every state of water is involved in that hydrologic cycle. So let's come to that portion only. Evaporation of water from water bodies such as lakes, oceans and lakes, formation and movement of clouds and snowfall, stream flow and groundwater movement are some examples of dynamic aspects of water. Dynamic aspects of water, we are talking about the movement of water from one state to other, and even flow of water in the same state. Like when the water is present in the oceans and lakes, it is continuous under motion. Then we are talking about the formation of clouds. It The movement of water is in the form of gaseous state, and it becomes the after when the evaporation occurs, the gaseous particles, the gaseous water, it rises and forms into the clouds. Then again there is precipitation or rainfall, and it falls down on the earth. So there is again the dynamic aspect. The water is continuously in motion in one state or other. Similarly, when the water, the clouds have occurred due to the evaporation, transpiration, okay, uh, the clouds have formed. Then there will be precipitation. Precipitation will be in the form of rainfall in low-lying areas, and in the higher regions in the mountains and glacial areas, it will be in the form of snowfall. Then again it will fall on the earth. Then after falling on earth, the snow will melt, or the water rainfall which is there in the precipitation, it will again start to flow towards the low-lying regions or towards the nearest stream. Then there will be nearest river or ocean or water body which is there. It will again flow in that direction. So similarly, the water, that means it is continuously in motion in one form or the other. Okay, it is continuously in a state of change. The ocean water does not remain water permanently. The water will become gaseous, it will form clouds, then again it will rainfall will occur, and it will again be converted into the water. Okay, so here in this animation you can easily see evaporation is happening, then condensation takes place, clouds are forming, then it is transported to other areas where the precipitation is occurring, like snowfall and rainfall. Transpiration is occurring, then the groundwater which is there, the runoff which is generated due to the precipitation, it is again coming back to the ocean. So here you can see all the steps of the process which are happening in a cycle process. Wherever you start this study, you will find yourself coming back to the exact same point, and this is a never ending cycle. The first is the evaporation from water bodies. The evaporation is occurring, then the water vapor moves upwards and the cloud formation is there due to condensation. At higher altitudes the temperature is less, so the water molecules condense and they become a cloud. So when the cloud is formed, then the cloud then transports itself uh, away from the cloud formation area, and it reaches the places where the pressure is low, and it reaches there, like here you can see on the dry areas. Then the precipitation is happening in two forms. One is the snowfall, the precipitate is forming, precipitation in the form of the snowfall and rainfall. It is happening again on the plains. Then when the precipitation is happening, it is then generated into the runoff. You can see in this direction it is showing that runoff is being generated. The water which is on the surface again starts to flow in the direction of the low lying areas. Okay, so it will try to come back to its original source of the ocean where it has all started its journey. Some of the water, see, you can see that what we were talking about, transpiration is happening. Transpiration occurs from the surface itself, like the plants which are there, the water molecules from the plants also get uh, evaporated. So that is known as transpiration, which occurs from the plant's body. That also happens, and it again goes up. Infiltration, some amount of water which is falling on the surface of the earth, it will infiltrate into the soil. Where the soil is dry, it will infiltrate into the soil, then it will go inside the groundwater, where the underground water, that infiltrated water will reach there, and that groundwater will try to flow in the low direction, in the low lying regions internally below the soil itself. So the runoff which is being generated is on the surface, like you can see that from the higher regions it is flowing. There may be some small ponds or that like such lakes are being created, but it will eventually try to flow in the direction of the low lying areas. So there will be stream flow, there can be river flow, then it comes back to the ocean. The water, then it is writing deep percolation. Deep percolation goes inside the underground soil, and there is groundwater. Groundwater, with the groundwater flow, it is also going towards the ocean side or the low lying areas, and this cycle is continuously going on. In the starting, when we had discussed that there is been always been a study that what is the water coming from, where it is going, what is the type of water, why the water is salty or why is it not salty. This all comes from this process only. Here you can see the water is coming and going. So when the water is in the resource stage, like if you are working in the plain regions over here, then your water source is precipitation and this stream flow. So according to you, the water is coming from a higher region flow and it is crossing you and going. Then you can create reservoirs like this, or you can create dams which you can store the water, then utilize it. Then you can see that why the water is salty or not salty. The water with all its these minerals, and due to the evaporation from ground, it comes into the ocean and it eventually it is becoming salty. Okay, and the groundwater which is there, it is not salty because due to the precipitation, when the water is precipitating in the form of snow or water, it is pure H2O. So it does not have any taste in salt or anything, only water is there, and it is flowing on the surface. It picks up a lot of dirt and muck with it, but when it is infiltrating inside the earth, it goes through the layers of the soil, and again the impurities which get locked in the soil surface, and the pure water goes inside the earth. Okay, so here you can simply understand the whole hydrologic cycle. Whichever point you pick on this cycle, you will see yourself coming back to the same point. This circle is continuously going on. There may be changes due to the region where you are living. The amount of precipitation and amount of transpiration, amount of flow may vary day to day, month to month, year to year, but the process, the cycle remains the same. So the hydrological surface has important influence in a variety of fields like agriculture, forestry, geography, economics, sociology, and political scene. How the livelihood of people is also depending on water, how much water is available over there, which cities, how much population can sustain over there, that everything, the economics, how much agriculture can be done. Agriculture is basically revolving around areas which have fresh water. So amount of the water you have, the more settlement you can have over there. Similarly, engineering applications of the knowledge are found in the design and operation of the projects, dealing with water supply, how much water we can supply, hydropower, like water supply, hydropower, we can create dams and use that stored water to create electricity, the hydropower, irrigation and drainage, how much water can be stored and used for irrigation purposes after the precipitation is done. If we do not collect the water, it will become a runoff and it is waste of resource for us. Flood control, if there is excess of water, we can have check dams which can store waters in small quantities and stop the flood to happen. Navigation, large rivers which have ample quantity of water throughout the year can be used by ships for navigation purposes. Coastal work, like the communities which live near to the coast, the whole economy is depending upon the coast itself, the resources used from the water like fishing and everything, that also is there. And various hydrologic structure works like river training works are there, dams, barrages, bridges are there, which we can, if we have the study of that water flow over there, we can decide accordingly what will be the height of the bridge, where the bridge should be located, like those studies can be over there. Then salinity control and recreational use of water. Salinity control, that this when the flood waters from the ocean should not spill into the irrigation area, then your crops get spoiled. And if we can desalinate the water, then we can use it as a drinking resource also. And recreational use of water is the fun usage we use in for the entertainment purposes or recreational purposes. That is also very required in areas which do not have much water. We can have systems to bring water to that area, and we can enjoy the fun associated with water. So in this video, I will only stop till here to just to get the idea that everyone uh, gets the simple basic thinking of what is hydrology, what is hydrological cycle, and you can start thinking that how much water is a resource to you and how can you can utilize that water. So thank you everyone for this video. I would like to end the video right here.